2022. It's my pleasure to invite for first lecture of this session Professor Natalia Kusul. It's my pleasure to invite for this presentation. Professor Natalia Kusul represents National Technical University of Ukraine, Igor Sikorsky Kyiv Polytechnic Institute. I think it's one of the longest name of our university, because in Kharkiv we have long name as well. Okay, I would like to say a few words about Professor Natalia Kusul. She is one of the most famous specialists in Ukraine, not only in area big data application for different tasks on ecology security, on application of different satellite technology, and so on. Thank you very much one more for your presentation, and let's begin our session. Welcome for this session. I ask about 40 or maybe 35 minutes for your presentation, plus 5-10 minutes for discussion. After that, next presentation will be from United States, our colleagues, Professor Andrzej Rusiński and Dr. Ted Kochanski. Welcome for session.
Thank you very much. Hello, everybody. I will talk today about big satellite data and artificial intelligence on this data for food and environmental security. In more details, we will talk about the following moments. First of all, briefly, I will tell you about our team, then about the current moment, which is the era of big satellite data, which inspires the development of artificial intelligence for this satellite data. Then I'll tell you about our findings in artificial intelligence and cloud technologies which are used to process this big amount of data, and what is the impact of this applied science. The impact is digitalization of the economy, the opportunity to solve or to develop some problems of food security, environmental security, and taking into account the current situation in Ukraine. Satellite data also allows us to assess the damages from the war, because they also influence food security and environmental security, not only in Ukraine, but all over the world. So who we are? I represent the Department of Mathematical Modeling and Data Analysis in National Technical University of Ukraine, Kyiv Polytechnic Institute. This department was created only in the beginning of this year, just before the war started. But before this, I, with my team, have been working together in Space Research Institute of National Academy of Science of Ukraine for about 25 years. So we have big experience in satellite data processing and different kinds of applications. We are deeply involved and try to contribute into international programs such as GeoGLAM, GCAM, Geo-Working Plan, and also we are integrated into European part of Group of Earth Observation EuroGeo project. And as a department of the university, we try to be integrated into the academic community into the Copernicus Academy. It is a network of universities who promote the use of satellite data in different sciences and different kinds of applications. So what is our main domain? Our main domain is Earth observation data, and 5 years ago, or to be more precise, in 2015, the new era of Earth observation started when European Space Agency started the program Copernicus, which include the launch of big amount of satellite data which are in operational use, so they guarantee providing the data during 20 years, and all this data are provided for free, not only for research purposes, but also for commercialization. With this program, new market of services emerged, and we can observe that since 2019 the market of satellite data services is increasing continuously, and it will increase 3 times till 2025. So right now it is a time of very intensive development of methodology and models based on satellite data. And as well as this amount of data is not big but huge, it raises the development of new applications of artificial intelligence and transition from just data receiving, data download, to analytics on this data and development of machine learning models and techniques and artificial intelligence methodology for solving real-world problems. I would like to pay your attention that artificial intelligence problem in area of Earth observation are real-world problem. It is not just the development or writing some fairy tales. It is about the estimation of real situation on the world, estimation of the origins of life in the world, estimation of trends, where we're going with our anthropological influence into our environment. So it is very serious and very responsive science. And during last years, we observe the increasing of number of national initiatives and big interest to this sphere from commercial companies and commercialization of the space science and launches of satellite data and satellite data processing is increasing every year. So right now we can talk about the scientific area, geospatial intelligence, and it is a discipline that involves the use and analysis of imagery, multispectral imagery and hyperspectral imagery, and geospatial information to describe, evaluate, and visualize geographic features, activities, and processes on our Earth with geographical reference. Traditionally, this term used in military context, and we used intelligence to spy something, to get involved in the information in other countries. But right now, this term is mainly civilian, and we talk about a lot of peaceful applications such as telecommunication, governmental sector, public administration, economics, And also geospatial intelligence in military sense, very important nowadays, and war in Ukraine justify it once more. Satellite data is only one of different sources of geospatial information in geospatial intelligence. But due to regular acquisition of this data and due to big amount of this data, it is very important and I could say the most influential in it. So how does satellite data looks like? Different satellites provide different kind of data with different resolution, and due to different orbit orientation, this information not homogenical, and we can see the examples of imagery from different satellites. In the left side are optical data. The left picture is Landsat satellite, American satellite, another one European satellite, Sentinel-2. It is also optical, but 10-meter resolution, despite of American, which is 30-meter resolution. And the right one picture is the image from radar data, radar satellite Sentinel-1, which provides absolutely other nature of information. And if we will look to this information closely, we can see that they look different and have different resolution, different volume of information, and requires different techniques for their processing. Moreover, some of this data, optical data, can be noised with clouds, or radar data also are noised due to the nature of data acquisition. So there is a big importance of development of automatical methods for satellite data processing, and to extract new levels of information, we should develop machine learning models for this, and artificial intelligence methodology. Which kind of machine learning tasks are solved in this area? It is traditional problems for machine learning, such as object and state recognition, thematic segmentation, classification problem, as well as clustering problem. There is the opportunity to develop methodology of forecasting and analysis of different trends based on series of observation. And also one of the big challenges in geospatial intelligence, as well as in other areas of machine learning, are data set generation, generation of labeled data sets for training and testing and validation the models. And this area has faces with challenges. They are partly traditional for artificial intelligence, for different domains of artificial intelligence, such as, for example, big amount of data, and in our domain it is over big amount of data that only big providers of cloud computing and cloud storages could store this data and provide it for users. And we have also specific challenges in this area, such as heterogeneous multimodal data, which we seen in the previous slide, as well as involvement of other kinds of data and information from other sources to solve real-world problem. So together with satellite data, we very often use meteorological information, socio-economical information, and develop some models which assimilate the information from regular observations and measurements. And as I already mentioned, the specific of our tasks is not that it is some fairy tales or art where we can imagine any object, but this area is very much user-oriented, real-life oriented, and it is the biggest challenge, I could say, because operational use of artificial intelligence in satellite data is very important and very challenging at the moment. So what is our place in this big area and very interesting area of investigation? First of all, we develop methods of machine learning on satellite data, namely land cover, land use assessment, and solve applicable application problems for satellite monitoring and geospatial intelligence. One of the most important publications from our team is the paper which was published in 2017. It was the first paper when we start to develop deep learning methodology, and starting from them we have developed a lot of different methodologies, starting from the pre-processing of satellite data, development of methods and models of machine learning for different classification and clusterization problems, and also for post-processing of the maps and solving of real-world problems with involvement of socio-economical information to deliver the product which is required by our government and by public. To develop machine learning methodology on satellite data, everyone requires ground truth information, and not ground truth information, but information, in situ information, to create the labeled data sets for training and validation of the model. That is why in this area there is an initiative, joint experiment on crop assessment and monitoring, JCAM. It is the initiative of Group of Earth Observation, and it's joined the labs all over the world. We can see it on the map on the right, and we as Ukrainian team involved into this activity since 2011 and pay a lot of attention on not only development of the methodology, but on its validation. How efficient this methodology, not only for a concrete territory for which it is tested and developed. For example, if Ukrainians, we develop our methodology for Ukraine, but climatic conditions all over the world are different. So nobody can guarantee that the methodology that is developed for one geographical area will be efficient enough for another. So within this GCAM network, we try to compare different methodology and try to schedule the standardized experiments for cross-validation and cross-testing of different methodologies. And our methodology is good enough. For example, in this experiment, when we checked the methodology for different countries, our was the best in 4 from 5 use cases. In Europe, one of the biggest initiatives and projects focusing on machine learning and big satellite data processing is the project ERA-Planet. It is Horizon 2020 projects, which is finishing right now. And it involves scientific groups from different countries and from Greece also, and from Ukraine. I mentioned Greece because now the DESSERT conference is hosted by Greece colleagues. Thank you for them also. So this project brings together 35 institutions from almost all the Europe, and it was focused on developing the methodology of applied problems solution in different areas, and we were involved into 3 such projects. One of them was led by the Observatory of Athens, our Greek colleagues, and it was devoted to development of the methodology for smart cities, smart urban solutions in terms of air quality, disasters, and city growth. And our role was there in adaptation and development of the methodology of city growth assessment and planning based on satellite data. Another one example of geospatial intelligence is use of satellite information together with information from different models, biophysical models, to estimate indicators of sustainable development goals. The idea is to compare real observations extracted from satellite data with their potential of productivity delivered by the modeling tools, and estimating the difference between the potential of our soil and the real observation. We can estimate where the land is degraded or where we have productive and sustainable agriculture. To solve these problems on this big amount of data, we should use cloud technologies, because to develop informational technologies of satellite monitoring for even for one country such as Ukraine, it is not very small, but not the biggest country in the world, we require not hundreds but thousands of satellite imagery, and it is not possible to download all this information on site. That is why it is very important to develop informational technologies and software based on cloud services, and the biggest providers of these services are Amazon Web Services, Google. It has specialized cloud for satellite data processing named Google Earth Engine. And also there is big efforts of European clouds. European Space Agency funds several cloud platforms. They called DIAS, and one of them, CreoDIAS, is providing facilities for development of artificial intelligence and machine learning models together with fast access to satellite data. And it is starting, it is emerging cloud technology, which will be matured and widely used during the nearest years. And European Union pay great attention to moving the technologies from traditional Google and Amazon Web Services to European cloud platforms. One of them is the project eShape, which is the flagship project of Horizon 2020. It provides the opportunities to move the models to European cloud platform. And our part of this project is also implementation of the indicators of sustainable development goals. Why we develop all this very expensive and very resource-consuming technology? Satellite-based intelligence provides the basis for Industry 4.0, 4.0, and for the digitalization of economy, not only in Ukraine, but also in Europe. Now in Europe, there is a program, Digital Europe, when till 2030, a lot of governmental tasks and public life should be digitalized, and satellite data is a driver of digitalization for economy. For example, we put a lot of efforts to implement our methodology in the Ukrainian government and to promote the European best practices and the European policies in use of satellite data for example, in common agricultural policy and other governmental tasks, such, for example, as statistics, governmental statistics. This year is very difficult for Ukraine because on February 24th, we faced this new phase of war. It is the big war, and if before this year only a small part, only 5% of the territory was occupied, it is shown in blue here, then after the big war started, the territory under occupation is approximately 20%, and it is 20% of our most productive cropland. So this year our efforts and our models were concentrated on estimation of the damages which were caused by war and on the influence of this process on food security in Ukraine and all over the world. A lot of fields, there are a lot of territories which are under the occupation, and Ukraine lose this crops, this harvest, and there are a lot of fields are under direct military actions, so they are damaged and maybe could not be used in nearest future for agriculture. Here we can see some examples of damages which are visible even in 10-meter resolution, coarse resolution for such purposes. But even in this free data, we can observe a lot of craters from bombing, and when we are looking into the high resolution data, very high resolution data, we can see much more damages which are caused by war. With our colleagues from World Bank, we estimated the losses influenced by war and quantified that in this year about 15% of yield were lost, and about 4 million tons of winter cereals was not harvested. So it is big damages, and the data source for this estimates is satellite information, and in current conditions it is the only objective data which we can get about the occupied and affected territories, because, for example, Ukrainian Statistical Office said that they has connections only with 60% of their respondents, so they cannot get the objective information in their traditional way. That is why very important that our international colleagues initiated the initiative EU for UA, when European Cloud CREODIAS, company Cloudflare operates it, initiated the creation of environment, cloud environment and scientific environment, where different players of research institutions, commercial companies, and other interested people organize exchange of information to deliver better products, to get synergized effect, synergized results on estimation, assessment of damages caused by war. And due to this initiative, we were able to run our models and deliver crop classification maps for previous year and for this year. And this information already implemented in our governmental state agrarian registry. This registry is established only this year to move Ukrainian governmental practices more close to European practices, because Ukraine now is associated member of European Union, and we have goal to become the full member of European Union, so we should do this, and our scientific group helps as we can. And comparing crop classification maps for previous year and this year, we estimated that the cropland areas in the regions which are affected by war significantly decreased this year, and this territory is the most productive agricultural regions, and it caused that cereals area also decreased comparing to 2021, and sunflower areas also significantly decreased. My colleagues will talk about this study in more details during special session, which will be organized after our plenary session today. So I think they will tell a lot of interesting and very sad facts, how this war influence Ukrainian economy and food security and environmental security, not only in Ukraine, but also in the war, because Ukraine is one of the biggest exporters of grain, of cereals, so it's not only our problem. And a lot of lands left non-cultivated for this year, and it is not the only one, it is not the only problem. A lot of damages were made with fires, because in the southern part of Ukraine there is very little fires. It is steppe zone, climatic zone, but along the front line of the war, all fires were, all forests were fired this year, so there is no forest in this part. While among these small territories, there are natural reserves of that are under the protection of UNESCO and internationally recognized natural reserves. Also, the very dangerous situation with winter crops in Ukraine, because the areas of winter crops is also less than it was earlier, and we estimated the winter crops areas for the next year. It is yellow in this picture, and comparing to previous year, we can see that in the southeast part, which are the most productive agricultural lands, the area of winter crops will decrease, and we expect that the harvest next year of winter crops will be less than this year, so it could cause to the more serious food security problems than we observe. So I tried to demonstrate that satellite information is the driver for artificial intelligence method development, for the digitalization of the economy. And I would be glad if in this conference we will find new partners for collaboration, for further study and investigation in this area. Thank you very much.
Thank you. Thank you very much for your presentation. And now we have time for discussion, for question and answer. Yes, you have a question? Of course.
Please, Professor Stopulaikis.
I have a question, and my question is the following. First of all, your presentation was excellent, and you are a superstar for Ukraine because your research is going to help Ukraine. But when you said that digitalization will help development of the industrialization, and when you said that the digitalization will also help city planning and urban development, I have the following question for the future for you. If you have time 5 years from now, 3 years from now, to do some research on the interference that modern satellite communication, digital communication have on 5G. Because as you know, China and the United States, one of the most important issue fighting against each other was who is going to be predominant in 5G communication, because this will make Netflix obsolete, and the economy of each country will be based on a bigger percentage on the development of 5G. So my question is that it will be very fruitful in the future to examine the interference between the 5G and the satellite, because I have read a few papers, modern papers, that say the development of 5G is slowed down because of the satellite interference. So this is one, if it helps you in the future, if you have a student who would like to get a PhD on this area, will be very important. This is my question. It's not something against your lecture, because it was a perfect lecture. And if I was Zelensky, I would give you a prize. But for the future, look at this area.
Yeah, thank you very much. Of course, while study one aspect of human activity, we should estimate the influence of it into another aspects and another domains. So, of course, this communication area, communication field such as 5G, it also should be related with other technologies, satellite technologies. So it's, I think it makes sense, of course.
Thank you also. Any more questions, please? Yes, please. Any more questions? Is anybody want some?
Yes, yeah, I have.
Thank you. Yes, yes. Yes, Professor Kowalski, please.
Yes. So again, a very fine presentation, especially under these very difficult circumstances that we're facing these days. One of the big concerns is, of course, goes by term sometimes hacking, sometimes disruptions of various kinds. How do you protect your data so that when you are faced with potentially disruptions of various kinds, is there a methodology that you have developed or employ, or do you do it on a sort of ad hoc basis? If something comes along and you say, "Oh, this is causing some different trouble with our sensors or something like that, or with our networks, or with the cloud," or what?
Yeah, you know, now in Ukraine with the big energetic crisis, when most of the day we have no electricity, it is very important to protect data and to provide sustainable process of data processing, because big data processing requires also time resources. And it is additionally to cyber security aspects. So in this aspect, cloud technologies are very important for Ukraine, and now many Ukrainian organizations move their even websites into clouds and don't host it in their own resources, because big providers can provide the duplication, the protection of the data, and part of the responsibility is on the cloud environment providers. And data which we work with are the open source data. It is initially free of charge data, open to anyone. So there is no big problem for us to protect the initial data. And I think that our results are also open to public, and we happy to deliver it to government, to public, and to be useful for them.
Thank you. Thank you very much for your answer for questions. Any more questions, please? Okay, thank you very much, Professor Kosul, for your lecture. Thank you very much. It was very useful for us. It was very nice. Thank you. Next.